Welcome to Biology My Passion. I am Soumya Harikrishna. Today we are going to learn another chapter in chemistry class 9, atoms and molecules. The philosophies regarding what is the composition of matter or what is matter made of had started as early as 500 BC. That time an Indian philosopher called Maharishi Kanad. So matter is called a Padarth in Indian language, and Padarth he found that it is made up of some small particles called a Paramanu. That means if you break the Padarth or the matter several times, finally you will get a Paramanu. Another philosopher called Pagoda Kateyama, he told that these are found in composition or in collection forming different matters. And Democritus and Leucippus, these two Greek philosophers, first told about something called atoms, which is actually the same, similar to Paramanu only, but they coined the term atoms. And then Antoine and Lavoisier only first proposed laws of chemical combinations, which gave us more idea about atoms. Now let's see what are laws of chemical combinations. Laws means it's more than one law included in this. Actually, these laws were confirmed after several experimental reactions they conducted in the lab and confirmed these laws. And also, these laws gave the confirmation of the idea that the smallest form of matter is atom, or all matter is made up of atom. And based on these laws only, Dalton proposed his atomic theory. So these laws include law of conservation of mass, law of definite proportion, and law of multiple proportion. But in class 9 we are studying only law of conservation of mass and law of definite proportion. Now what is law of conservation of mass? In energy we say law of conservation of energy, right? The same way here also, law of conservation of mass states that mass can neither be created nor be destroyed. So the total mass remains the same before and after a reaction. For example, this was given by Lavoisier in 1774. So I told it is based on several experimental reactions they confirm these laws. So if you say take a simple example, carbon and oxygen. Okay, we get carbon dioxide. So if you take the individual weight of carbon, you know that these two substances, carbon and oxygen, which are involving in a reaction, they are called the reactants. The one which is going to react are called the reactants. And what we are getting are called the products of the chemical reaction. So in a chemical reaction, reactants combine to form products, or reactants break to form products. So different types of chemical reactions are there. So whenever we are writing, usually we write the reactants to the left hand side and products to the right hand side, separated by an arrow mark. The arrow will show the direction of the reaction, that is from reactant to the products. So here what are the reactants? Carbon and oxygen. What is the product? Carbon dioxide. Suppose if I take the individual weights of carbon and oxygen, for example, let carbon be x grams and oxygen be y grams, but when I measure the weight of carbon dioxide, it will be x plus y grams. That means before and after the mass remains the same. Okay, so here the total reactant will be x plus y, product is also x plus y, so law of conservation of mass. Or another example, calcium carbonate. If I take calcium carbonate 100 grams, okay, and I am heating it, okay, this will show heat. So when I am heating it, I will get two products. One is calcium oxide, or we call it as quicklime, and carbon dioxide. Okay, so 100 grams of this will get divided into 56 grams of calcium oxide and 44 grams of carbon dioxide. But I know if I add this 56 plus 44, I am going to get 100 grams. So the total mass of the reactants and the products are the same. So the law of conservation of mass is confirmed here. Now in your textbook, they have given three pairs of substances or chemical substances which you have to combine to verify this law. In this, if you take the second combinations, that is barium chloride and sodium sulfate, you can see the activity here. That is, you are taking conical flask. Into that conical flask, you have to insert a small ignition tube, means a small test tube. So both these apparatus you have to weigh first and keep away their measurement or their weight, you note down. Then after that, take the sodium sulfate solution in the beaker and add the ignition tube with the second component, that is barium chloride. Then you weigh the mass again. After that you tilt the barium chloride so that it gets mixed with the sodium sulfate. As a result, we will get barium sulfate and sodium chloride as the product. A white precipitate of barium sulfate will be forming in this reaction. But after that, again, if you take the weight of the product after combination, you will get the same difference will be there. If you subtract the weight of the apparatus, you will see that initially what we took 5% solution of barium chloride and 5% solution of sodium sulfate, and finally we are getting barium sulfate and sodium chloride. Both have the same mass. So from this we understand that the law of chemical reaction is true. The next law is law of definite proportion. This was actually observed by Lavoisier again with some other scientists. They checked different compounds and they found that in each compound there are more than one element, but the compound has a definite proportion of these elements. Whoever prepares, suppose I prepare or you prepare or another person prepares, the same compound if we prepare, it's a combination or the proportion is the same, or the materials that we have to take is the same. The law of definite proportion states that in a chemical substance, always the elements are present in a definite proportion by mass. We can understand this using two examples. One is our water. So we know that water has hydrogen and oxygen. Both of them combine to form a molecule of water. So always we see that 1 gram of hydrogen combines with 8 grams of oxygen to get 1 molecule of water. So what is the ratio here? It is 1:8. The same way there is another compound called ammonia. Ammonia has nitrogen and hydrogen. It gives the compound ammonia. Okay, here also the ratio is 14:3. So 14 parts of nitrogen by mass is combined with the 3 parts of hydrogen by mass. So this proportion does not change. So if you take any molecule, for example seawater or tap water or the rainwater or the pond water, always water molecule will have this proportion. If we want to get water, you have to add hydrogen and oxygen in the ratio 1:8 by mass. If you change the ratio, you will get another compound. Understood? The same way, if you want to get ammonia, you have to take nitrogen and hydrogen in the ratio 14:3 by mass. This is called a law of definite proportion. So, but these scientists could not give much explanation to this law of chemical combinations, or so later Dalton took up this. So his basis was this laws of chemical combination, and he gave atoms theory, or he used the same word used by the Greek philosophers atom for implying or indicating that matter is made up of the smallest particles called atoms, or he called indivisible particles called atoms. The basis for his theory was these laws of chemical combinations, and through his laws he gave explanation to the two laws in the laws of chemical combinations, which are the law of conservation of mass and law of definite proportion. Now let's discuss Dalton's atomic theory. According to Dalton's atomic theory, all matter, whether it is in the form of element or compound or mixtures, they are made up of small particles called atoms. So now let's see what are the postulates of Dalton's atomic theory. First one, all matter made up of small particles called atoms. Second, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Third, atoms of the same elements have same mass and properties, chemical properties. Atoms of a given element, for example, suppose I take carbon. All atoms of carbon are same in its mass and chemical properties. Atoms of different elements have different mass and different chemical properties. For example, if I take the mass of carbon atoms, carbon is an element, hydrogen is another element. The atoms making that element carbon will have the same mass and the same chemical properties, which will be different from that of the mass of hydrogen atoms or hydrogen chemical properties. Okay, so these are the 2 points, the third and the fourth points. Now these carbon and hydrogen, they can combine to form compounds, but how do they combine? Can it be half of carbon and 3/4 of hydrogen? No, they always combine in the proportion of whole numbers. For example, suppose 1 carbon with a 4 hydrogen, we will get methane. So like that, whole numbers proportion, they combine to form compounds. The relative number and the kinds of atoms in a given compound are the same. For example, ammonia, as I told, always it will be nitrogen and hydrogen in the ratio 14:3 by mass, or 1 nitrogen combines with the 3 hydrogen. Initially we told that Dalton's atomic theory is based on law of combination of masses, laws of combination of mass, and also he verified the law of conservation of mass and law of definite proportion. Let's see how he verified that. First of all, the second postulate, if you remember, atoms are indivisible particles and can neither be created nor be destroyed. So if you take that part, can neither be created nor be destroyed, so that is nothing but the law of conservation of mass by Lavoisier. Then elements consist of atoms having fixed mass, and the number and kind of atoms in a compound is fixed. That means 2 points combined here. One we told, suppose carbon is the element, all its atoms have the same mass and chemical properties, and in a compound like ammonia, the mass of the atoms like nitrogen and hydrogen in a compound is fixed. Number and kind is fixed. I told only 1 nitrogen and 3 hydrogen, or in the mass ratio 14:3, only we will get ammonia. So these two if you combine, that is nothing but law of definite proportions or law of constant proportions proposed by Proust. Okay, so these two laws are verified by Dalton's atomic theory. But when we further did experiments in this field, we came across certain demerits of this Dalton's atomic theory. Let's see what are they. The disadvantages of Dalton's atomic theory are listed here. First, Dalton told the atoms are indivisible particles. That means we cannot divide atoms further. Any matter, if you keep on dividing, you will finally come to atoms. After atoms, no more division is possible. But later, now we understood that even atom can have 3 different particles in it. They are called subatomic particles. Electrons, that is negatively charged, protons, positively charged, and neutron, neutral charge. Okay, so that theory is proved wrong now. Now next is, we learned that atoms of the same element will have same mass and chemical proportion, we said. But there can be slightly different masses for the same atom. For example, carbon. Carbon can exist as carbon 12, where the mass is 12 unit or mass unit, whereas carbon may exist in mass with a 13 unit, or it can have 14 unit as well. So element is the same, carbon, but its masses keep changing, 12, 13 or 14. Actually such condition is called an isotope. We will learn about it later. So that way it is proved wrong. Now the next point we told was atoms of different elements will have different mass, right? Carbon mass is different from mass of hydrogen, but that also sometimes proved wrong. For example, argon, potassium and calcium are the elements having the same atomic mass, that is 40 unit. So though they are different atoms of different elements, their mass remains the same. So that point is also proved wrong now. Hope you understood these concepts clearly. Please like, share and subscribe to my channel Biology My Passion. Thank you for watching.